Hello, everyone. My name is Martina Welander. I am an education engineer here at Prisma and primarily responsible for writing documentation in my team of now 2 documentation writers. I am a former developer that decided to write docs and also a Swede that decided to move to Denmark. And you can follow my inability to make up my mind about anything on Twitter and GitHub with the links on your screen now. And I'm here today to accompany you to the world's worst pool party. We are starting Prisma Day with a primer on all things connection management and Prisma. And for those of you that are already well-versed on this topic, there will be plenty of cartoons to enjoy instead over your morning or nighttime coffee. And I'm doing this presentation because I suffered through writing the docs. So this is essentially a dramatic reading of the connection management guide. And you can find the fruits of my bitter writer tears on the doc site if you search connection management. And there I am crying over text, just another Tuesday. So onwards, today you're going to meet a varied cast of characters, all hand-drawn, that includes your long-suffering database and all its needs and limitations and demands. And of course, Prisma, with its little pool of wriggly connections. It's a pool that can be configured and tuned to maximize throughput, and we're going to learn how to do that today. Our story takes us through the following 4 questions, things to ponder in the pool. So first of all, why does a database get tired? What does it mean to exhaust your connection limit? What is the Prisma Client connection pool, and how exactly does it work? And how do I tune and configure my solution to get the very best out of my database? And last but not least, what's the big deal with serverless connection management, and why should I be a little bit scared? So let's dive right in, no apologies for the pun, with why does the database get tired? So I'm going to use Postgres as an example for most of these. And you might have seen an error message like this one, connection limit exceeded. Or maybe this thrilling message, sorry, too many clients already. This is your database telling you that you have reached its configured connection limit, which for a plain old Postgres database hosted locally is 10 with 100, cannot read, with an additional 15 for super users. If you're using something like Heroku, their dev and basic starting tiers give you about 20 connections. And if you're using Amazon AWS, then this fancy little formula calculates how many connections you have and your connection limit. And for TT too small, it's about 198. So it all depends on what you're paying for and where your database is hosted. And no matter how fancy your database is, it's going to respond like this if you make too many connections at once and stress it out. Limit exceeded. So no more connections allowed. It's just going to not serve you. And that's because connections use RAM. And if there's no more RAM allocated to create connections, then there's nothing the database can do. And you're like, okay, well, sorry, I had some unexpected traffic, or my app is just growing. I'm selling cake. It's really popular right now. And you might, in your mind, think, can I just increase the database connection like a little bit? And I'd say, yes, you may be so bold. And eventually, most apps need a slightly chunkier database, but not as the first step. So here's why. If you have a hosted database, it's probably going to cost you, especially if you're just using an increased connection limit to put a Band-Aid on another issue. And if you host it yourself and you are responsible for the hardware and you decide to set a really high connection limit, then a great mother operating system might eventually shut down your database because the amount of RAM being used is threatening her general well-being. So to start with, what we need to keep the database from getting exhausted and too tired is a pool and a queue. And that brings us on to the first bit of our architecture, which is the Prisma Client connection pool. So connection pools, I mean, the Prisma aren't the first people to come up with a connection pool. It's a fairly common concept, but I'm going to tell you how this one works. So the Prisma connection pool dictates the maximum number of concurrent connections that an instance of Prisma Client will open to the database. And this value is configurable, but there is a default based on the number of CPUs you have, and we'll look at that formula later. So when your client starts up, queries start coming in, boom, there's your pool of connections. And here is how this connection pool works. So first of all, the query engine generates queries. For instance, get me all the blog posts, insert these orders, filter these plumbuses, or delete all of the dingle hoppers, whatever your business model happens to be. These requests are handled by a little pool of available connections, so our Brave 4 that we've created for example purposes. And they take these requests and send them on to the database, which apparently I've decided is right through its brain. And Prisma will never let more than 4 simultaneous connections through, and the database doesn't get overwhelmed. So it's just a happy story. Pause for water. Then the other cool thing is, if there are too many requests coming in, they get added to an orderly queue. And I really do mean orderly. It's a first in, first out queue. So the first query to come in should be the first one that's dealt with. And you might, in a moment of scaling mischief, ask yourself, can I just let the queue grow and prevent the database from becoming overwhelmed? And sometimes, but we'll get to that. So not really, because there is this timeout. And queries will expire if they're in the queue for too long. Kind of like in that movie In Time, where people die once their clock runs out. It's really morbid. I've tried to capture the horror of the movie in this diagram here with the little SQL query getting sad because his friend's exploding. You can actually disable this timeout if you think this is too traumatic. And let the queue just grow. But then you really need a lot of RAM because it's an in-memory queue and therefore a potential RAM gobbler. And a long queue of queries also means a potentially longer waiting time for a response, so tread carefully there. There are some instances where it makes sense to really increase the timeout or disable it completely, but we'll get to that a little bit later. All right, so you have a pool now and you have a queue. It's all very exciting. Let's tune and configure the living crap out of this pool. Starting with something completely unrelated to configuration settings, and quite a common problem that we see cropping up, and that is that you need one Prisma client to rule them all in your app. So I mean, instantiate Prisma client once and reuse it. And here's why. When you instantiate the client, you create a query engine, or an instance of the query engine, and you create a pool with our 4 little cuties here. And if you instantiate clients all over your app every time you want to use Prisma, you create many clients and therefore many engines and therefore many pools. And Prisma, this is important, does not currently do anything under the hood to merge these instances. So what you're going to end up with is you think you have a pool of 4, but you have so many client instances that you might have a pool of 30. And now you get this error again because you're passing on too many connections to the database and it gets tired. So making sure you only have one instance looks something like this. I'm going to show you a part of an Express app that hosts a GraphQL API. So here we have the root of the Express server. And inside app use, you pass in a context. And in that context object, you have your Prisma client. And that Prisma client, because it's exported from this module, it gets cached and reused across the entire application. And you can guarantee that there's only ever going to be one connection pool. Related to this, somebody somewhere on GitHub had this splendid idea that you can use a linter to make sure there's only ever one instance of the client. It's really useful if you have a big project or disparate teams that don't necessarily talk to each other. So you'd make up a rule that says only one instance of Prisma client, and then you'd get a warning if you try to create more. While we're on the topic of Prisma Client, let's go through a couple of extra Prisma Client tips that are related to connection management. So tip number one is that there's no need to explicitly connect or disconnect. Prisma connects lazily when the first connection is made. You can, of course, call connect if you need an instant response, but you don't have to do it. And for our purposes, disconnect is probably more important, because if you disconnect every time you issue a query, you then have to reconnect again next time, and establishing a connection takes time. So you should reserve explicit disconnects for when you're running like a one-off script to do a job and you really do want to disconnect, but you don't need to do it in a long-running application like a website where you don't need to disconnect because you're always serving requests. So that's a little performance tip. Next is next.js. Tip number two. If you're using Prisma with Next.js and you're using hot reloading in a dev environment, that's to see changes as you develop your app. That's cool. But to do that, Next has to refresh the module, potentially to refresh the module that exports the Prisma client. And remember, we're relying on caching to have only one instance. So you might see in a dev environment, another client being created or multiple other clients, and suddenly you're exhausting your connection limit in a dev environment, and that might be really concerning. But all that's happened is that the caching isn't working as it should in a Next.js context. There is a workaround on the doc site that you can search for, but in short, you need to store the Prisma client as a global variable and just do that in dev environments. So that means it doesn't get cleared. So that's another Prisma client tip whilst we're talking about the Prisma client. So you have a pool, you have your client. Let's tune the pool. So in case you missed it, here's our pool. And we have a couple of configuration options at our disposal. The first option is called connection limit. That's not to be confused with database connection limit. That's configured on the database end. This is the maximum allowed pool size of connections, these little guys. And we'll talk a little bit about the specifics of this setting. So it's calculated by this formula by default. So if you have 2 CPUs times 2 plus 1, that's 5 as your maximum connection limit. But you can also set it manually by appending connection limit to your connection string. The pool size should generally be less than the database connection limit, so you're not letting through more connections than your database can handle, because that would be mean, I think. And also be aware of other apps accessing the database. So if you have multiple apps with connection limits accessing the same database, and you got to share, you got to be nice to each other. So that's the connection limit parameter. The second one is this pool timeout. And that concerns that queue we were talking about of queries coming into the pool. And this setting determines how long queries sit in the queue until they expire. And as we said, if you have a really massive queue, you're eating up RAM, and you're also potentially delaying the response time. So why would I ever use this parameter? Well, there are some scenarios that make sense. So let's say you're importing several 100,000 rows as part of an update job that you run every week. You're going to be submitting batches upon batches of update queries, and you just want them to be handled at some point. So you might actually be okay with the queue getting quite large. In fact, you might not only increase the wait time, you might just disable the queue entirely because you have the RAM and you're just doing it, and that's fine. So that's one of the scenarios where it's sort of okay to have a massive queue and take up a bunch of RAM and just let it do its thing. But ultimately, it's about balance. So achieving some kind of balance between what your database can handle and making sure your requests are handled in a sort of sensible time frame, and paying ideally as little as possible for the actual database. So a lot to think about. So that's a connection pool and how to tune it and configure it and when. So I feel like, now we're older and we're wiser and we're done and know because serverless. All right, let me tell you about serverless, because this caused me quite a lot of pain when I was trying to figure it out. serverless, and connection management. So here's the challenge. And I'm going to be using AWS Lambda as an example. And in AWS Lambda, you create these little Lambda functions. And the idea is that they spin up, they do a task like book a room or buy a cake. They have they've isolated unit of functionality, and then they're done with their job. And you can use Prisma on board this little Lambda function. And as you can see, it has a connection pool. Now, imagine this happens. So for one night only, rooms are very discounted, or cake is very cheap, or whatever your business model is, and you get a massive spike in traffic. It's beyond what you had anticipated from the point of view of your database tier. It's just crazy. Luckily, you have AWS Lambda, and behind the scenes, Lambda scales to meet demand, and that is what it's supposed to do. So you're going to get copies of these functions running like, okay, yeah, take in the bookings, do it, cake, wow. Which is a good thing. It's what it's designed to do. Here's the problem with databases, though. Suddenly you have 200 concurrent Lambdas, and each of them has a Prisma client, and each of those has a pool. Let's go through that slowly. You have 200 concurrent Lambdas floating about in space. You have 200 separate Prisma clients also floating around in space. Each one of these has maybe, let's say, 5 connections per pool. I think that's what the default ends up being if you don't set it explicitly. Just some seconds here to do some maths. That's suddenly 1,000 connections because of this spike. That is a very large and scary pool of connections, which equals a very scary database. It just wasn't prepared. So that's the problem with serverless. The functions scale, but the database does not necessarily scale, or at least not that fast. So you might end up losing queries because your database can't keep up. So what can you do? We're going to start with some small potato stuff. First of all, you can instantiate your client outside of the function handler. That means this. You can see there's a new Prisma client above the handler, and that is supposed to increase the chance, but absolutely not guarantee, that your instantiated client gets reused. You have no control over when AWS decides to close down a container and spin up a new one, but this gives you a chance at least. The second thing you can do is set your connection limit parameter, your pool size, to 1. And what this does is Prisma will only allow 1 connection through at any one time. The net effect being that in your swarm of Lambdas over here, each one is only able to open 1 connection. And you might think, oh, but aren't the queues going to get enormous? Isn't it better just to have more connections? And the answer is it depends. So setting the connection limit to 1, it might be appropriate if 1, you are not using a connection pooler. More on that in a couple of seconds. And if you've designed each of your Lambdas, or if you've designed your Lambda function not to run a huge number of concurrent queries, then you're not going to have a queue. It's going to spin up, do its 2-3 queries, and done. So the queue shouldn't add a lot of waiting time. All right, let's say you've done all this, you're still exhausting your connection limit, especially during traffic spikes, which is the big problem. You might even have set a concurrency limit for your Lambdas, but you're like, oh, but then I can't, then it doesn't scale in that wonderful way. So the answer to that is that you might need a bigger pool, specifically something called a connection pooler, and specifically something called pgbouncer. pgbouncer is supported by Prisma. You make a few tweaks to the connection string for your database, and then you can use it. pgbouncer, in my mind, would look something like this, the strongest, swollest database and pool in all the land. And the way it works is it sits between all the Prisma clients coming in, all the Lambdas, boom, there it is, and the database. So as connections come in, pgbouncer pulls them and also puts them in a queue and only passes them onto the database when the database is ready. So it's like a super mega pool, the great defender against the Lambda horde. And generally, this is a pretty good solution to the serverless challenge for traffic spikes and that sort of thing. And now we're kind of coming to the edge of my research for the docs, but what lies beyond pgbouncer? So I had a little bit of a chat with everyone at work and a little bit of a research. And here's just some things you should consider. Beefier databases and different architectures, aka the end of my knowledge and aka food for thought. These are just ideas. So for instance, you might want to consider a database architecture that's been built for serverless, like Aurora Serverless v2. It was launched in December 2020. It's still in preview, I believe. And the thing here is that you don't choose a database class size, you choose a range. So you are anticipating, that kind of scaling. It auto scales on demand, apparently quickly. I haven't tested it myself. And with something like AWS RDS, which does scale, I think you had to scale manually, which isn't what you want. So that's the promise of Aurora Serverless anyway. And I can see that loads of other vendors are starting to do a similar thing where they want to help you solve the serverless problem. So option one, beefier database, which is always good. But of course, it's going to come with costs. You might also want to start to think, is my architecture really suited to how my app has evolved? So the second thing to think about is architecture. And I'll leave you with this final picture of a cake and some words. So I've been thinking, perhaps you have one layer or one horde of Lambdas exclusively responsible for handling incoming requests, like buy a cake. So you scale out infinitely to capture all these requests for cake. Maybe you then write these requests to a highly scalable queue instead of directly to a relational database. Perhaps you then have a second Lambda responsible for reading these messages. The Lambda uses Prisma Client. It has maybe a concurrency limit, so it never gets out of hand, which is an AWS Lambda thing, like how many concurrent Lambdas can I have? And maybe it sends queries in bulk with a create many to avoid stressing the database. So you've separated your architecture out into two parts: the data collection piece, which needs to be able to handle a fire hose of data, and the writing to the database piece, which maybe can take a bit more time. It's just an idea, not preaching by any stretch. And now you know as much as I do about connection management with Prisma. And I hope I have given you a decent overview of connection management in general and the sort of buttons and levers you can modify or tweak in Prisma. I hope I've given you ideas to research, or if none of that, I hope I have given you a good laugh to start your Prisma day. Thank you very much for your time.
Our very first question is, AWS has its own connection puller called RDS proxy. Does Prisma support RDS proxy?
So you can use it, but it will not give you any benefit. And that is because Prisma Client uses prepared statements. And when RDS proxy receives a prepared statement, it will pin your connection. So your horde of Lambdas will come, your queries will come in, and because they're prepared, you'll get a pinned connection rather than the connection being able to be reused for all the incoming queries. So you just won't get any benefit from using it, but you can, but there's no reason to really.
I see. And now pgbouncer only works with Postgres as far as I know. Is there an equivalent for users who are using MySQL?
So nothing that we have tested. I think there's even a live issue to try Proxy SQL as an alternative. So you can follow that on the Prisma GitHub issues list. But I think Postgres, it's quite expensive to make connections, and I think you have maybe less of an issue with MySQL. But I think it's on the list to be investigated.
All right. We also have an upcoming talk about planet scale, so I'm sure that we'll get a chance to get a look at that from the perspective of planet scale. We have one more question. So you mentioned that you need this sort of connection parameter when using pgbouncer with Prisma Client. Why is that weird connection parameter necessary?
Okay, so if you use Prisma, which I'm sure all of you do, you have a connection string, and then you have this little, by the way, use pgbouncer at the end. And you might wonder, like, why do I need that? And here's why. Again, it's to do with Prisma using prepared statements. And in order to send a prepared statement onto pgbouncer needs to be in transaction mode. And that is because with pgbouncer, if you're not doing everything in transaction mode, then it might prepare the statement on one connection 1. You've made your pasta in your restaurant, and then try to run it on connection 7. So it's, you're not going to put your pasta on your plate. So in order for these two things to happen simultaneously, and for the connection or the query to go through, Prisma needs to know, like, oh, hey, I'm about to send something to pgbouncer. I need to do it in a transaction, even if it's just reading some data. So it's a way to tell Prisma to do certain things slightly differently, because the sort of hole that's filling its connections into expects something different. So that's why you need that little parameter to change Prisma's behavior slightly.
I see. Let's see if we have any more questions coming from our audience. So we had Dries, who made a comment, I'm never going to think about pgbouncer the same, thanks to Martina's cartoon. So thank you for the cartoons.
Oh yeah, that was a horrifying one. It was the last one I drew, so it was, the well was pretty dry at that point.
Yeah. All right. And if there aren't any more questions coming in, I'd like to thank you again, Martina. It's always a pleasure viewing your talks, and hope to see you soon.
Thank you very much. Enjoy the rest of Prisma Day, everybody.